manufacturing, technology, hot topics, and a little bit of tomfoolery. This is the MTD Podcast.
Welcome to today's MTD Podcast. This is episode 10 today.
And good to know that Mr. Fowler is back.
He is, yeah, Tom.
Yeah.
And you know who else is here today?
Nope.
Mr. Albanese.
Hi guys, how you doing?
Gio, don't shake my hand.
You've been a bit poorly, mate, haven't you? You seem to have recovered now, though.
Hopefully, yeah, on the men, fingers crossed. It's been a bit.
Is that why you have a gas mask? They don't breathe on us at 30.
What was it in the end?
It was tonsillitis gone wrong, and then it turned into a Quincy.
Paul,
Yeah.
So
this is a short programme, we ain't got
fingers
time.
crossed. Yeah, it's gone now. So
Because you even missed the football, didn't you? Which was a shame.
I was
You would've won
quite
that
gutted
without.
about that. Yeah.
Colin, you all right? You have a nice weekend? It was Valentine's night the other night, wasn't it? Are you,
Paul,
did you get out and about?
I got ghosted, stood up, blocked, whatever.
Did you? All three of them?
All three, yeah. So I had a quiet night to myself, but it was very enjoyable. In fact, one of the most enjoyable nights I've had in ages.
Good.
Can we move on swiftly?
We can. That always shuts you up when we talk about your love life. Right, okay, so today we're going to be talking about EDM machining. That is our hot topic for today. And Colin's got something he's going to say.
What's EDM, Paul?
It's electrical discharge machining.
And how do you know that?
And there's because I've got it written down in front of me.
Exactly.
Yeah. Lots of, that's what we're going to be talking about. So a bit of an open forum. Let's get it underway.
So EDM, what is it?
Electrical
discharge. What is a process,
machining. So it's a process of either using a wire to cut components, using a combination of electrical discharge and relevant water, if that's the right way of saying it.
Dielectric.
Yeah, that's
lovely
the word I was looking for. And also, or then you can spark using electrodes to create different forms, and then you can also use EDM drills as well. So there we go.
Fast hole drilling.
Fast hole drilling.
Gio's nodding in the back, so that means Paul's right.
He is right. We've been doing a bit of research. I mean, I've got to admit, I'm no specialist in this arena at all in any way,
What
shape,
arena
or
are you a
form.
specialist in, Gio?
Not many, to be fair.
Do you know
However,
they use a similar process to get your tonsils out?
Wow, blimey! I'm definitely not having that done then, Paul.
And then what about you then, Colin? What do you know about it beyond what I've said then? Let's start. Well, let's break it down. Let's talk about
right.
wire first.
No, hold on. It is an electrical current, so it needs to be conductive. It will do really hard materials, including PCD. Do you know what PCD is?
Yes.
Yeah, it's pitch circle diameter.
No. How's that material? What's PCD, Gio?
Polycrystalline diamond.
Oh, there you go. Look at that. You learned something. We learned a lot.
But do you know why you can actually use PCD?
Because it can take a current.
Because it's got a high carbon content.
Yeah, but so's a diamond.
But not as
apparently
high
not.
as PCD.
Oh, yeah. There you go. So you've got conductivity, electricity running through your wire, your electrode, or on your drill thing.
Bit.
That's it. Yeah.
Bit, yeah.
Creating a spark.
Yes, yeah, but actually EDM. Well, let's take each different discipline individually. Let's start with.
We worked with you long enough. There's no discipline going on, is there, mate?
Let's start with the wire. Now, with wire cutting, is it an accurate method of cutting a part out, Joe?
Joe, where's Joe?
Yeah.
God, you wouldn't miss him if he was in
Yeah,
there.
apparently you can cut to less than 5 microns accuracy, but not only the accuracy nowadays, you've got the surface finish. So one thing I learned as well, you can do like roughing cuts and finishing cuts, so you can get surface finish, like mirror surface finish. So you look at a lot of components, and many components need profiling. So for profiling, it's a great way of doing it, especially on them exotic and hard materials.
Absolutely.
And how do they get that surface finish though with a wire? This is what kind of.
Well, the wire's not touching it. It's a spark, and they change, as I understand it. Correct me if I'm wrong, Gio, because you were also listening more than I was. The spark, the voltage, and the ampage. So they change out to get different surface finishes.
Right. Okay.
And it was interesting because at High Tech they've got an old Wickman, and straight away you're thinking multi-spindle lathe, correct?
Well, yeah, multi-spindle. Yeah,
They got an old Wickman EDM from 1980. It's got the old manual control, and they love that machine because they can control the voltage, ampage, all sorts of things, and the length of the spark and things like that. Length of time the spark is sparking across for.
But you must be able to do that on new modern technology as well.
You can,
it's
but
evolved. It's
but each-
evolved significantly.
changing like the length of spark in terms of time, you have to use different lines of code. So you have to look up certain lines of code. So, I've got to change it. They've got to look through a manual. Whereas this one, they're just pressing the buttons and they can control it. They They don't use it very often, but they do love it.
Yeah.
Anyway, moving on.
But so wire cutting though, what's an application that you would want to wire cut as opposed to machine?
Well, for me, I think this is really, again, going back, I'm not a specialist in EDM, but from learning what it actually does and the applications, I've really seen some fantastic applications that it really lends itself to. And I just want to clarify one thing in detail. We're not trying to say that EDM is going to take over milling machines. Not, absolutely not. However,
Depends who you're working for, Gio.
there are certain applications it's absolutely perfect for. So we touched on, let's start. There's some very complex components that can't be done on a milling machine that you've got to do on an EDM. But there's components such as gears or profile parts of exotic materials, or even pre-opping on an EDM machine. So using the combination of a milling machine and an EDM and doing all the work that needs to be done on a milling machine, and it's making you money on the milling machine, and work that doesn't need to be done on the EDM. I think having a combination
That was the longest
of the
answer to
two,
what sort of parts?
many parts.
Thin walls.
Yeah.
Thin
So
wall components,
you've milled out a component and you need some thin walls so you can go through the inside, for example, with the wire. So you can't hold that part in a milling machine because it's going to be too delicate. If you're going gears, maybe, if you're going in with a mill, you're going to get burring potentially. With the wire, you won't.
Yeah. And with the wire as well, though, it does have to go, the cut is right the way through the part, which is different to sinking. And the thing is, with the modern technology, which your colleagues that you spoke about, high-tech aerospace wouldn't be able to do, is things like auto wire feed. So for example, if the wire breaks, they would have to go in and manually change wires.
On the old Wickham, but the new ones.
On the new technology.
On the new technology, yeah, that's what I mean.
But it's so good. Previously, we went there a couple of years ago and it was running dielectrical water through it to pick the wire up and guide it through. Now the new Sonic machine, and was it VR300L from
Can't
memory?
remember the code, but yeah, maybe.
Correct. Sorry, I could get it wrong. But that doesn't even need that. It will feed itself. It's absolutely amazing.
And I believe that the Fanuc does exactly the same. But you know the
and other machines are available.
Correct, yeah. But the beauty of that auto wire feed is not only just if something breaks, but you imagine if you had 300 holes that you need, or say 300 holes, you had 5 or 6 holes that you needed to get into in order to start cutting. You wouldn't have been able to do that before. You'd have had to have manually fed the wire through, stop the machine, then the next move on to the next one. So that's it would have become unproductive. It would be like you cutting something out with a hacksaw.
It's also really
hacksaw. Down in the cellar.
On his arms.
Yeah, different story. Moving on.
Gio,
you don't have to put your hand up. You have to go. No, that's enough from you, Gio.
It's also a really nice feature to have for unmanned running. So, you've not got no tools. If the wire was to break, it would reload itself and it would go back to exactly the same position from when it broke. So you've got confidence in unmanned running overnight, no problem whatsoever. And the running costs are low.
They are. What about, do you know what?
I'm going to step in and take a step back. Radiuses in the corner.
Yeah.
If you're milling that, for example, you're going to get a slight radius. With the wire, you can get that 90-degree angle. I know it's a podcast. I'm doing all these sort of actions in the background, which people clearly can't see.
Karate Kid.
Yeah, I can catch a grasshopper.
Question.
With a chopstick.
Question for you.
Question.
What is a core stitch function?
Gio knows the answer.
In a few weeks.
Do you know?
Yeah, no, Gio does know the answer.
Do you know that? Yeah. No. So a core stitch function is that you imagine if you're cutting out of a bolster, is that the right word, or a big block? And you're cutting a form out of a big plate or what have you. You're cutting a form out. You imagine when the wires gets down to the very last bit, a bit when you're using your hacksaw in your garage and you're cutting through your bit of metal or whatever it is you're cutting through. When you get to the end, what happens when you get to the point that you started to the point that you finish? It falls out lands on your foot, doesn't it?
What's when you're sawing a branch and you're sitting on the wrong end of the branch?
Correct, yeah. So the core stitch function, what that does is it actually stitches it all the way round as you're cutting it. So at the end you tap it and it falls out.
Oh, so like not quality, terry chocolate orange. Tap it, unwrap it.
I don't eat chocolate, but yeah.
Clearly do.
But yeah, so you tap it the part out, and the core stitch function keeps it in place, so you don't.
Aren't you going to have not burrs, but little sort of?
Yeah,
webs?
but you can knock them off.
Okay.
Yeah,
that's quite.
So
clever.
it's very clever. It's something that the Fanuc machine does offer. That, and again, other models of machines and brands that are available.
Maybe Sodic or Mitsubishi as an example.
Absolutely, yeah.
Moving on from wire though, what about die sync or sync? Looking at God, yeah.
Well, I think that, wire, you've got to be able to go all the way through the part. So a profile, for example, if you've got a blind pocket, for example, then you need to use an electrode, and you can literally just profile your electrode on your wire machine, on your EDM machine, and then use that electrode to create the pocket, not machine out the pocket.
So it's like a cavity, isn't it?
It
would spark out a cavity. Conversely to what a wire does, where it cuts all the way through.
Why wouldn't you mill that cavity then?
Well, you could mill that cavity. But it might be a challenging material.
Scottish brother.
It might be a challenging material, or it might be you possibly could do it.
We saw some parts at High Tech Aerospace. It was an engine part where they've got that. It had a radius at the bottom.
That was impossible to machine.
Correct. Yeah. I'm glad you dug me out of a bit of a hole there, because that would be a reason. Yeah. If the corners were, or the radiuses weren't of such that you could do with a machining centre, then that's why you would need to use it.
Yeah.
But we were talking to the guys at Ward High Tech, and he definitely is the godfather of EDM manufacturing.
Ward High Tech or High Tech Aerospace?
High Tech Aerospace, Collins. Sorry about that, guys. But he was explaining to us all the applications that he does there, and it weren't just for them really complex components, it's for kind of standard components as well. They've also got milling machines there, lathes there, but there's certain parts that do lend themselves to EDM. And for me, my question is why not as many people using EDM as maybe they should be?
I got another question, right? How many EDM machines, approximately new, wire, spark, drill, would you say it's sold in the UK market in a year?
Not many, because you think of how many engineering companies there are around here. How many? They might have one or two EDM machines there compared to all their mills and lathes or whatever. How many specialised? I can't think of many specialist engineering companies. So I'm going to take a stab at 58.
Gio?
About 100.
It's about 150.
Oh, really?
Yeah.
I thought it'd be a lot more.
Still, statistics that have been supplied to us, approximately about 150. But you say that to me, I think that's nowhere near enough. I think it should be. But
that's because they last so long. Those Sodic machines that Bob and Neil Martin have got at High Tech. We keep going on about High Tech, but we did. You might guess that we visited them recently. Yeah. Some of those Sodic machines have been going on for years and years. They really have. Absolute.
But is that because as well with an EDM machine, the wear and tear, the process that's actually happening? If you take like a lathe or a machining centre, there's a lot more stresses, isn't there, on the machine tool? I would have thought there's a lot more. It's a completely different operation. With an EDM machine, you're just talking about sparking. So, things like vibration aren't really an issue. So that could affect wear and tear.
I don't believe that's the reason why there's so little sold, because of the longevity.
No. But that's probably why they last many years.
Yeah, totally agree. Yeah,
I think it is quite specialised.
But I think there should be more and more sold. I think you have an example of when you used to work somewhere where you had an application.
Yeah, for the fast hole drilling, for example, as an example there, this is just one of many applications. But knowing now what I know, that when I was at an aerospace company, we had a component that was approximately about 15 mil long, about 10 mil diameter, with a PCD of about 8 holes. That was about 0.8 holes, diameter holes, that went all the way through the length of the component. And we drilled them holes through these little components. And you can imagine the amount of time it took to drill them holes out. We were running the spindle of the machine at maximum RPM, and there was obviously no money in that part whatsoever. We were running the parts as a loss leader. So that milling machine was running at a batch of these parts a month, taking up that machine probably a week at a time. Running these parts, not making any money on the parts, scrapping lots of the parts due to drill breakage, and eventually actually even blowing up the spindle, because the spindle was being run at maximum RPM.
Did you get through your apprenticeship all right, Gio? So what was the diameter of the drill, sorry?
0.8 diameter drill. So, I can't remember, exactly all the...
Because I thought you could only, in terms of when you're drilling, you should only go 8 times the diameter in terms of length, something like that. Is that right?
If you're machining, yeah. But I mean, when you take moving on to the EDM drill, because that
Well, what the point I was trying to get to,
Let him
really,
finish, Paul,
they should have been done. I can't remember the exact dimensions. It's going back about 10 years, but approximately them kind of dimensions. They should have been done on an EDM machine, which would have freed up that milling machine to mill parts that it should have been making money on. And that's the kind of points that we're trying to get across here today. And that's just one example that came into my mind.
So fast hole drilling, we're moving on, a nice segue into fast hole drilling. But before that, you threw out some statistics.
Yeah.
You said about 152 machines, you say?
Ish.
Approx. Okay. Yeah. How hot is that spark when it's sparking a metal?
What do you want the answer in? Fahrenheit, Celsius?
I think the level it goes to is going to make not a lot of difference. Kelvin, actually. There you go.
Kelvin.
Who's he?
Didn't he sell LNS bar feeds?
He tries to.
I don't know. 2,000 degrees.
Gio, I'll give you a clue. It's higher. Let's say 2001.
10,000.
Lower. Oh, we're going to be here with 8,000 degrees C.
Bob Monkhouse.
Yeah, 8,000 degrees C that will burn up to,
Wow.
or spark up
Really?
to. Yep. So don't touch it or lick it. It's hot.
Okay. So on the drilling then, on EDM drilling, do you know what this process is?
Well, again, electrical current going through the drill, which is spinning, same as a normal drill, but it's actually got a hole down the middle of it for the dielectric to go through and flush out the dirt, whatever it is.
Put it on Wikipedia.
Yeah. You know that date that blew me out on Thursday night? That's what I was doing. I was learning about EDM. So dielectric's going through there. So you'll have electrodes down to 0.35 either way, so absolutely minute. I think they were going up to 8 mil in diameter, and it will go through really tough materials. PCD, polycrystalline diamond, if I'm correct.
See,
No,
I've got written down here.
notes.
No, I've got written down here, which is why. How deep can it drill in a minute?
It depends on the material, Paul.
Yeah, approximately.
In a minute, I'd say 3 centimeters.
3 centimeters. You know, you've been reading the same.
I read it.
thing
That was good.
an EDM
that was a
drill
guess.
is rotating tube conveying a pressurized set of dielectric fluid. Right. It can drill an inch in a minute, and it's good on hard materials. For example,
Such as?
like cool.
PCD. Boom, I'm here all day.
Such as cooling holes for aeroblades or cooling holes and aeroblades.
Well, I know it's a podcast, but if our editors are any good, no pressure, Will, who's sitting around the corner watching, we've got some great pictures to go with this.
Yes.
Of me.
Yeah. Did you know that, Gio, about EDM drilling?
No, I didn't know. I've learned some facts there.
So typical application, though, very deep holes that you wouldn't be able to machine on a machine tool. And like you say, from difficult hard materials.
Also, two-way compound holes as well. When you've got tiny little holes of 0.3, 0.8 diameter where you've got to put the hole in on a two-way compound, that again is perfect because the drill would just drift if you're trying to drill it.
Yeah. How many people do you think don't know the sort of stuff that we've been speaking about today?
Well, there's 3 around here in the podcast.
I mean, how many engineers out there just think, it's spark eroding, it's, because it moves on so quickly.
A great example, Paul, and not wishing to make you look like a complete plonker.
Yeah.
You've already done that. I remember asking you ages, about 3 or 4 years ago, what's EDM? And you go, well, Colin, it's, you know what, I don't really know. And you, in all seriousness, you've been in industry, 30 odd years? Since you were 25? And you didn't actually, I mean, you can mill, you can turn, you can leg it, absolutely. But EDM, you weren't sure. So
No, I know. But I mean, how many topics are there like this that, really are you unsure? But I've learned a lot. I've learned a lot by researching this. But I do think that the things to make a point of it, how fast it moves on as well, and how many changes there are in the technology in order to break down the barriers to entry on things like surface finish, and accuracy. Now, all of these things have been addressed, and I think a lot of engineers won't know that. I think there'll still be machining parts that they could do unmanned. The cost per hour that you were going to mention, Gio, weren't you?
Yeah, I think there's a few points really in that is that one, I think people are unaware of it. I think there's a lot of companies that are subcontracting all their EDM work out, thinking that it's only for them problematic parts that they can't machine. And they probably don't think of embracing that technology because they're scared of it. They've never used it before. They might be scared of the programming, the setups, but it's absolutely dead simple. So they could start machining them complex part that they're currently subcontracting out and having full control over them parts. But then they can start introducing other work that they didn't realise that they could use on their EDM as well. So they could double up and become more profitable as a business.
I don't want to contradict you there, Gio, but I'm going to. You make it. It is a relatively straightforward process, etc. But you need to be skilled. I mean, Bob Martin at High Tech and other guys around the country. They are real craftsmen. So much knowledge and experience.
Well, it comes back. A lot of it comes back to tool making. You know, a tool maker. I did an apprenticeship as a tool maker. And
made a hammer,
made a mess. But tool makers are notoriously skillful, aren't they? You know, it was a trade and an art in itself, and you know that hasn't changed. A lot of those guys have, as a result of being tool makers, used EDM technology throughout.
But I think as an engineer in general, you know, you've got to be skilled. You've got to be skilled at milling. You've got to be skilled at turning. I think that you've got to be that way inclined. And I think that if you've never tried that technology before, you need to at least give it a go and investigate it.
And we learned something today.
Yes,
absolutely. So, there we have it. Hopefully you have, and of course, join us next time. This has been episode 10 of the MTD podcast. No doubt we'll be back same time next week.
See you guys.
Bye bye.
Bonjour.